Hi students, sometimes if we touch a metallic knob of the door, we might get a mild shock. A comb which is rubbed with dry hair is kept near to the small pieces of paper, then it attracts those small pieces of paper. Two individual glass rods are rubbed with two silk cloths separately are kept beside, then they repel each other. A glass rod which is rubbed with a silk cloth and that silk cloth are kept beside, then they attract each other. Two glass rods which already rubbed with silk cloths are brought in contact with two pith balls A and B and separated are kept beside. Then they repel each other. The quantity behind in all these cases is electric charge. Now we will see about electric charge. So electric charge is a property of a body or a particle. Due to this property, it produces and experiences electric and magnetic effects. So electric charge is a property of a body or a particle due to which it produces and experiences electric and magnetic effects. And we can write this definition also. So electric charge is a fundamental property of matter and never found free. The meaning of here never found free term means charge cannot exist without mass, but mass can exist without charge. That's why charge is a fundamental property of matter and never found free. Around 600 BC, Thales of Miletus was observed that when amber is rubbed with a silk cloth or wool cloth is kept near to the lighter objects, then this amber attracts those lighter objects. In Greek, electron means amber, and the term electricity is derived from the Greek word that is electron. Electrostatics or static electricity is a branch of physics which deals with static electric charges or charges at rest. In a simple way, we can say like this: electrostatics or static electricity is a branch of physics which deals with electric charges at rest. There are two kinds of electric charges, namely positive charge and negative charge. This was proposed by Benjamin Franklin. So, charges are two types. How we can distinguish these two kinds of electric charges? By using a property which is called a polarity of charge. So polarity of a charge is a property which helps in differentiating two types of electric charges. So polarity of a charge is a property. What is the use of this property? With the help of this property, we can differentiate the two types of electric charges. Source charge. The charge which is producing the electric field is called a source charge. So, source charge is a charge which produces electric field. So, the charge which is producing the electric field is called a source charge. Test charge. It is a small positive charge which does not affect the other charges present. So, test charge is a small positive charge which does not affect the presence of other charges, and with the help of this charge we can determine the effect of other charges. So test charge is a small positive charge which does not affect the presence of other charges nearby, and with the help of this test charge we can determine the effect of other charges. Point charge. When the linear size of a charged body is much smaller than the distance, then the charged body is called a point charge. So when we can say a charged body is a point charged one, so when a linear size of charged body is much smaller than the distance, then the charged body is called a point charge. Conductors and insulators. The substances which easily allow the flow of electric charges through them are called conductors. The substances which easily allow the flow of electric charges through them are called conductors. Insulators means the substances which do not allow the flow of electric charges through them are called insulators. So conductors easily allow the flow of electric charges through them. Insulators means which do not allow the flow of electric charges through them. Electrification. The process of making a neutral body into a charged body is called electrification, or the process of giving charge to a body is called electrification. So either one we can write. So electrification means the process of making a neutral body into a charged body is called electrification, or the process of giving charge to a body is called electrification. Here the charge which is given to a body, it may be positive charge or negative charge. There are three methods to make a neutral body into a charged body. Modern view of electrification. Every substance is made of atoms, and atom consists of positively charged nucleus at center, and around it negatively charged electrons revolve in different orbits. So this positive and negative charge are well balanced in an atom, so atom is electrically neutral. Suppose if we remove some electrons from a neutral atom, then deficiency of electrons that creates positive charge. If we add some excess electrons to a neutral atom, then that atom will be like a negatively charged one. So the excess or deficiency of electrons in a body gives the concept of charge. The deficiency of electrons in a body is known as positively charged body. The excess of electrons in a body is known as negatively charged body. If a body gets positive charge, means some of the electrons are removed from that neutral body, so its mass slightly decreases. If a body is given negative charge, means some of the electrons are added to that body, so its mass slightly increases. Methods of electrification. So how we can convert a neutral body into a charged body? By following these three methods. First one is charging by friction. Second one is charging by conduction. And third one is charging by induction. Now we'll see the first method, charging by friction. When two bodies are rubbed together, electrons are transferred from one body to the other. So, when two different bodies are rubbed together, electrons are transferred from one body to the other. The substance with a higher electron affinity gains electrons and hence it becomes negatively charged. The one with a lesser electron affinity loses electrons and becomes positively charged. So, the substance with a higher electron affinity gains electrons. After gaining electrons, excess of electrons will be available, so it will become negatively charged body. And the one which is having lesser electron affinity loses electrons and becomes positively charged due to its electrons deficiency. In this method, bodies acquire equal and unlike charges. So, when two bodies rub together, electrons are transferred from one body to the another body. In this case, one body gains electrons and another body loses electrons. The body which is gained electrons will become positively charged body, and the body which lost electrons will become negatively charged body. Means by using charging by friction we can get two unlike charged bodies. Electrostatic series. So, just see this electrostatic series for glass, silk, human body, cotton, wood, sealing wax, amber, resin, sulfur, rubber, and ebonite. The body appearing earlier in the list is positively charged, whereas the latter one is negatively charged due to charging by friction. We'll see now one example. Let's take glass and silk cloth. Glass and silk, which is appearing earlier, glass, which is appearing later one, silk. So when glass rod rubbed with the silk cloth, the one which is earlier one, glass, loses electrons to the silk. So glass rod will become positively charged one and the silk cloth will become negatively charged one. We will see with help of animations. Next, we'll see the charging by conduction. If a charged body is kept in contact with an neutral body, so a charged body is kept in contact with a neutral body, then the neutral body becomes charged. After conduction, both bodies acquire of same nature. So conduction precedes repulsion. Next method is charging by induction. When a charged body is kept closer but not in contact with it. So, when a charged body is kept closer to a neutral body, charge is induced in the neutral body. This induction due to realignment of charge in the neutral body. So, when a charged body is kept closer to a neutral body, charge is induced in the neutral body. This induction due to realignment of charge in the neutral body. The nearer side of a neutral body, the side which is near to the charged body gets unlike charge and the further end gets like charge. Induction precedes attraction. Inducting body neither gains nor loses the charge. Gold leaf electroscope. A simple apparatus to detect the charge and nature of charge on a body is the gold leaf electroscope. With help of this gold leaf electroscope, we can detect charge and nature of charge on a body. We'll see now how to detect the charge on a body and how to see the nature of charge on a body one by one. First, we'll see how we can detect the charge on a body with help of gold leaf electroscope. When a charged body touches the metal disc at the top of the rod, charge flows onto the gold leaves. Since both gold leaves are having same kind of charge, as we know that like charges repel and unlike charges attracts. So since these two gold leaves are having same kind of charge, they diverge. The degree of divergence is an indication of amount of charge. So if the charge present on the body is more, then degree of divergence will be more. Now, a positively charged body like a glass rubbed with a silk cloth is brought in contact with this metal disc. Then some of the positive charge is transferred from glass rod to the gold leaves through the metal rod. Now these two gold leaves are having positive charge, that is having same kind of charge. That's why these two gold leaves will diverge. Now a silk cloth which is rubbed with a glass rod is brought in contact with this metal disc. Then these two gold leaves will fall back to their original position. It means that earlier we made contact this metal disc with a glass rod which is having positive charge. Now the silk cloth brought in contact with this metal disc again. So the charge which is present on this silk cloth is negative. That's why the negative charge on the silk cloth and the positive charge on the gold leaves both gets nullified. That's why now there is no charge on this gold leaves. That's why both will fall back to their original position. In this way we can detect and in this way we can detect the charge and the nature of charge with help of gold leaf electroscope. Next topic is basic properties of electric charge. So these three are the basic properties of electric charge. First one is charge is additive, second one is charge is quantized, and third one is charge is conserved. Now we'll discuss about charge is additive. Charge is additive. First we'll see the example and later we'll see the statement of this charge is additive. If a system contains n number of charges like Q1, Q2, Q3 and so on Qn, then total charge Q is equal to Q1 plus Q2 plus Q3 plus and so on plus Qn. From this total charge Q is equal to Q1 plus Q2 plus Q3 plus and so on plus Qn, we can say that the total charge of the system is the algebraic sum of all the individual charges present within the system. So the total charge of the system is the algebraic sum of all the individual charges present within the system. Next property is charge is quantized. Every charge is an integral multiple of a basic unit of charge, that is electron. So in this universe, every charge is an integral multiple of a basic unit of charge, that is electron. So Q charge is equal to plus or minus Ne. Here n is equal to integer, that is 1, 2, 3, and so on. And E is the electron charge, that is equal to 1.6 into 10 power minus 19 coulomb. According to this, charge is quantized. Charge is always transferred from one body to another body in the form of integral multiple of charge of an electron. So, suppose two bodies I have taken, body 1 and body 2. From body 1, one electron is transferred to body 2. So here, which one lost electron? Body 1. Which one gained electron? Body 2. So body 1 lost 1 electron. So it lost 1 electron. That's why it gained a positive charge, and the charge of the body 1 is 1.6 into 10 power minus 19 coulomb, and this is positive charge. And body 2 gained 1 electron, that's why its charge is minus 1.6 into 10 power minus 19 coulomb. So charge is transferred from one body to another body in the form of integral multiple of charge of an electron. The quantization of electric charge was experimentally verified by R.A. Millikan by using his oil drop experiment. The minimum charge possible is 1.6 into 10 power minus 19 coulomb. So what is the minimum possible charge value? It is 1.6 into 10 power minus 19 coulomb. If a body having n1 protons and n2 electrons, then net charge on it will be Q is equal to n1 minus n2 into E. We will see with help of examples which charge is impossible in this nature and which charge is possible in this nature. We will see now example 1. Charge is equal to 3 into 10 power minus 19 coulomb. This one we need to write in terms of E. So 3 into 10 power minus 19 coulomb, we can write 1.875 into 1.6 into 10 power minus 19 coulomb. So 3 we can write 1.875 into 1.6. So 3 into 10 power minus 19 coulomb is equal to 1.875 into E. Here 1.875 is not an integer value. That's why this charge is impossible. Second example, charge is equal to 3.2 into 10 power minus 19 coulomb. This one we can write like this, 3.2 we can write like this. So 3.2 means 2 into 1.6. So 3.2 into 10 power minus 19 coulomb is equal to 2 into 1.6 into 10 power minus 19 coulomb. So 1.6 in 10 power minus 19 coulomb is nothing but small e. So that's why 2 into e, here 2 is the integer value. So this charge is possible. So in this universe, any charge, it should be in the form of integral multiple of basic unit of charge, that is electron. Now we will see the third property, that is charge is conserved. The total charge of the isolated system is always conserved. So, the total charge of an isolated system is always conserved. This is known as law of conservation of charge. So, according to this, charge can be neither created nor destroyed. Next property is charge is invariant. Charge is invariant means charge does not undergo any change due to its motion. Whether it is at rest or in motion, charge does not change. That's why charge does not undergo any change due to its motion. And another property of electric charge is a scalar quantity. So charge is a scalar quantity. And one more property is there, that is like charges repels and unlike charges attracts. Now we'll see the differences between electric charge and mass. Electric charge, it may be positive or negative, but mass is always positive. Second point, electric charge is a scalar quantity, even mass also a scalar quantity. Electric charge is invariant, whether the charged body is at rest or in motion, charge on that body is always constant. So it doesn't change with the speed of the body. Mass of a body changes with velocity of the body. Electric charge is always conserved, but mass is not conserved always. Charge cannot exist without mass, but mass can exist without charge. So, charge cannot exist without mass. Mass can exist without charge. Example, neutron. Neutron doesn't have any charge, but still it has mass. And charge is quantized, but mass is not quantized. And last point is electric charge is a derived physical quantity, but mass is a fundamental physical quantity.